Hello, ladies and gentlemen. Today we're going to be talking about how to graph rational functions. It's kind of taking everything that we've done so far with them and putting it all into kind of one big thing to kind of create this this thing that we can get, this graph that we want to look at, a sketch of it, okay? So let's go ahead and let's take a look at the first problem here. So there's going to be a couple steps that I want you to follow, so you're going to want to make sure that you have these written down, these steps you're going to follow to graph these rational functions, okay? The first thing that you're going to do is you're going to find the roots of your rational function, okay? So the very first thing is to find the roots. In order to do that, remember, that means setting the numerator equal to 0. Okay, we set that numerator equal to 0. For this one, we would go ahead and we set the numerator equal to 0, and we're going to get 0 as a root. Now, we're going to be graphing, so we want to make sure that we get a x value and a y value, so we have a point for that. So we want to make sure we write it as a coordinate 0, 0, okay? We, of course, know our x value is always going to be 0, so it's just, okay, what's the y value that comes with that? It's going to be 0 in this case, x equals 0. That's our answer, okay? All right, so that's number one. That's how we find the roots, okay? Setting the numerator equal to 0 and solving, getting our x and our y is always going to be 0. Number two, you are going to find your discontinuities. Okay, number two is finding your discontinuities. And remember, to find those, you are going to set the denominator equal to 0. In addition to finding them, you're also going to be identifying them as well. Okay, what kind of discontinuity are you dealing with? Are you dealing with a vertical asymptote, or are you dealing with a removable? And what's nice about the way I have this set up is that if something is a root and then it shows up as a discontinuity, you are going to know that it is removable. And we'll talk about when we have one of those, what we do with that in a moment, okay? But for these discontinuities, I'll set this denominator equal to 0. So I'll say 0 equals x squared minus x minus 2. I'll factor to solve. In this case, we're going to get that 0 equals x minus 2 times x plus 1. And I'm going to get two discontinuities. I'm going to get a discontinuity at x equals 2 and a discontinuity at x equals negative 1. And both of those, neither of those show up as roots, neither of these factors will cancel anything in the numerator, so both of these will be vertical asymptotes, and I will label them as such. Number three, the third step you would do would be to deal with your removable discontinuities. And we'll talk about what that looks like in a moment, because in this problem we do not have any. So that will come up later. Our next example will have that. Okay, but number three is to deal with removables, and we'll deal with that in our next example and see what that looks like. But in this case, we don't have those, so we can skip that. For number four, the fourth thing you're going to do, you're going to look at the end behavior. This is where you're going to figure out your end behavior by looking at those leading terms. You're either going to have a horizontal asymptote or a slant asymptote. In this case, when we go ahead and we look at this, we are going to have a horizontal asymptote at y equals 0. Okay, how do I know that? My numerator is a lesser degree than my denominator, so y equals 0 is going to be my asymptote. Okay, the fifth thing we're going to do is we're going to find a y-intercept. Okay, to find your y-intercept, you're going to plug 0 in for x and see what comes out. In this case, if I plug 0 in for x, I'm going to get 0 out, so 0, 0 is my y-intercept. You'll notice that also was my root, so really I'm not getting a new point from this, but if it does have a different y-intercept, that's another point we're going to get for our sketch, okay? The last thing is really the only brand new thing, okay? We already know how to find roots, we already know how to find discontinuities, we already know how to find end behavior, we kind of know how to find y-intercepts, we've done that before, plug in 0 for x. The removable thing we'll see in a moment, it's a little bit new, but not that new. The sixth step is really the brand new thing, okay? And that is our plus-minus chart is what we'll call it. Okay? A plus-minus chart is what's going to tell us where our function is in different positions. Is it going to be positive or negative? Okay? Here's how this works. We're going to go ahead and we're going to draw a line, and we're going to put on this number line any important points. And the important points I'm looking for are from number 1 and number 2. Any discontinuity and any root is going to go on this line. So, for example, here I'm going to have negative 1. I'm going to have 0. and I'm going to have 2. And then what I'm going to do is I'm going to test a point that falls in between each of these lines, okay? What do I mean by that? I'm going to pick a number that falls in between all of my roots and my discontinuities. So for example, I want a number that's less than -1. Let's say I pick the number -2. Okay, that's less than -1. That would be in that range. I could then pick a number in between -1 and 0. Let's say 0.5 or -0.5 or half. A number between 0 and 2, let's say I pick 1, and a number greater than 2, let's say I pick 3. What I'm going to do is I'm going to plug in these numbers into my function and see if I get a positive or a negative number out. Okay, I'm going to plug a number in and see if I get a positive or a negative number out. You can use a calculator to do this. You can just think about if your numerator and denominator is positive, whatever you got to do, plug it in and see if you get a positive or a negative number. We don't actually care what the number is. We just care if it's positive or if it's negative. So for example, I'll plug -2 in. So I'm going to say, all right, I'm going to do -2, and I'm going to divide that by -2 squared minus -2 minus 2. And I'm going to get -1/2. So that means that these values are negative over here. They're going to be negative, okay? Then at -0.5, I'll plug that in, so I'll do the exact same thing. So in this case, we're going to do -0.5 divided by -0.5 squared minus -0.5 and then minus 2. All right, and we get 0.4, which is a positive value, so this would then be positive, okay? And then the same thing over here, we'll go ahead and we'll plug in 1, so we'll do 1 divided by 1 squared minus 1 minus -2. That one will get a negative value, so we'll put a minus here. And then 3, we plug that in, 3 over 3 squared minus 3 minus 2. For that, we'll get a positive answer, and we'll put that here. Again, I don't really care what the number is, I just care if it's negative or positive, all right? What this plus minus chart is going to do is it's actually going to tell me about what the values are in these intervals, okay? It'll make more sense when we get to step 7, our last step, which is going to be to actually draw the sketch, okay? So here's how I'm going to draw that sketch. I'm going to start by drawing myself a little XY axis. Okay, so here's my little XY axis going to draw. Again, this is a sketch, does not have to be perfect. I'm going to plot my important points. So I'm going to start by plotting my roots. I have a root at 0, 0, okay? I'll plot my vertical asymptotes. I have one at 2 and one at -1. So I'll go to 2. I'll go to -1. To show a vertical asymptote, I'm just going to draw a dashed line at those points to show the vertical asymptote. Okay? I don't have to worry about removables because I don't have any. End behavior at y equals 0. If you have a horizontal asymptote that's on an axis or a vertical asymptote axis, draw a slash line there. Okay, so you know that it's there. Okay, so I have a horizontal asymptote there. Y-intercept was the same thing as a root, so I have to redraw that, and now I get to the plus minus chart. Okay, your asymptotes, okay, your vertical asymptotes, and then the end behavior asymptotes at the end are going to act like barriers. Okay, your line's not going to cross those. What you're going to do is you're going to know what your equation is doing, what your graph is doing based off of this plus minus chart. So for example, I know that from -1 to infinity, my graph is negative. I also know it has to follow this horizontal asymptote. So what I'm going to do, and let me switch my pen color here, is I know that my line is going to be following this as it goes out, but in a negative spot. And then when it gets to this asymptote here, it's going to follow this down and never cross it. And again, it's going to be negative this whole time. So I know I'm going to draw in the negative here. The next section from -1, I know I'm going to be positive. So I know that my graph's going to reappear up here in the positive location. It's going to go down. It's going to hit this root. Okay? And then it's going to become negative. It's going to cross, become negative, and go down here. Last but not least, we're going to have positive, and it's going to follow my horizontal asymptote out forever, again being positive. Your plus minus chart is helpful because it actually tells us a little thing about the way our functions work. A function can only switch from being positive to negative either at a root, we talked about that a little bit with polynomials, or at a discontinuity. A discontinuity is another place it can occur. So if I know that one value is negative, that's less than -1, I know all values are negative up until I get to a discontinuity here at -1. And then I know everything from -1 to 0, if it's positive, everything there has to be positive because the only place for it to cross are at roots and at discontinuities, okay? So I can kind of follow along with the things that I have, my important points, my vertical asymptotes and my roots, in addition to knowing what's going on at the ends with my horizontal asymptote. You'll notice in the middle here, we crossed the horizontal asymptote. Mr. Guy, how can we do that? The horizontal asymptotes are end behavior. They're end behavior. They're what's going on at the ends of your function. In the middle, you can cross them. At the ends, you cannot, okay? Go ahead and watch the next video to see another example and kind of get another look at how we're going to do this process.